guys to hear homework 96. Let's do this. Mineral questions. Okay, so make sure you read this, okay? This is very important. I'm not going to do it here. This needs to be read. Trust me. Basically, it goes down to which zone would the mineral potassium feldspar be placed. So these are harder than glass, metallic, luster, cleavage. You need to look here. Potassium feldspar, okay? And you need to look that it is harder than glass, but does not have a metallic luster, and it does have cleavage. Therefore, it will be in D. So this requires a good degree of sort of figuring that out. It can't be anywhere in here. Okay, so it has to be these, and D kind of shares those. So that's that can cause some problems for people. State the name of one mineral on the reference table that cannot be placed in any of these zones. Okay, so check this out. You want to use this. And so this is harder than glass, so it has to be not as hard as glass. It has to be non-metallic, and it has to not have cleavage. Okay, so if you look at that, what you're going to come down to is you got to try to figure that out. Non-metallic has to be one of these. Has to be what? Not harder than glass, so lower hardness than glass, so it's one of these, and then not have cleavage, so it really could be sulfur or hematite. Hematite's odd, but most kids put sulfur here, so sulfur or hematite. Sorry if that's unclear. Sulfur or hematite. Either one of those will work as an answer. Number 3. There's the table below, some properties of 4 different minerals. The minerals listed are varieties of which mineral? So you have flint, chert, jasper, chalcedony. None of those you know. Hardness of 7, luster non-metallic. That's the composition. So it does say non-metallic, so you got to do non-metallic one of these. Look, the hardness of 7 is right here, but the real giveaway is this, is the composition. SiO2. It is quartz. So it could theoretically be here because it's sort of in that range, but it's the composition that gives it away. Therefore, the answer here should be quartz 3. Hopefully you're seeing this. This is the type of stuff that is going to be on a mineral test. Here we go. This requires some reading. Make sure you read this. State one reason for the decline in global asbestos use after 1980. The best answer is something like because asbestos causes health problems. It causes problems with people's lungs who are exposed to it. It gets stuck in their lungs. Something about health problems here. That's the best answer for 4. 5. Determine what determines the physical properties of minerals, such as the long, stiff fibers of some varieties of asbestos. Answer. Best answer is the, you could say, the atomic structure of the minerals, the internal arrangement of atoms, okay, how the atoms are bonded together, but we usually like to say atomic structure or internal arrangement of atoms. That is what matters and gives it the mineral's properties. Chemical formula for this mineral is that. State the name of the mineral that is most similar in chemical composition. So you have to kind of look around here. Okay, so some of this is just looking stuff up. And what you're going to get, you've looked up and down here, and there's a lot to look through, but you're going to end up on here. Talc. Right? It's pretty darn close. Just some of these silicons and oxygens are a little different, so the ratios are off a little bit. But the answer here should be talc. 7. Which property is most useful in distinguishing pyroxene from amphibole? So you got to look here. Pyroxene, amphibole. You look here. They have similar hardness. Both have cleavage. Color's the same. The formula, you can't know the formula from looking at it. And it's this. It's cleavage directions. 2 at 90 degrees, and this is at 56 and 124. So the answer, that's angles of cleavage, is choice 4. Okay, this is review. I threw this on here for review. Sling cycrometer, your wet bulb is 15, dry bulb is 20, 20 degrees, 15 degrees. Difference is 5 degrees C. You look in the reference table. What are we looking for? We're looking for the dew point. So we want to look in the reference table, if you guys can remember this. We have the dry bulb temperature of 20 with the difference being 5 right there. So it's 12 degrees Celsius. And it needs to be 12 degrees Celsius. Anything else, percent, degrees Fahrenheit, are all wrong. 12 degrees C. Now, as a check, what I'm going to ask you to do is find the last 2 digits of your locker number. Once you do that, you will find the 2 letters that go next to it, and they're all random here. And then, please write them next to your name on the front. Make a box right there and write that number in there. Thank you very much. That should be a review. Number 10, here we go. What 2 elements that make up the 2 elements that make up the largest percentage by mass of Earth's crust are oxygen and what? Earth Science Reference Table, page 1. The crust, and the key word is by mass, because what you have here, the crust of Earth, by mass, which is kind of by weight, and by volume, which is space, how much space it takes up. We were looking in this column. It gives you which one? It gives you oxygen. And the second one, like percentage-wise, that's 46% for oxygen. The second one is silicon, 28. So that should be a choice, and it is. It's choice 1. 11. Student created a table based on a single property. Group A, Group B. So you got to really look around. How are these common? How are these all? What do these have in common? And if you realize. You got to really look around on the reference table. You're not going to know off the top of your head at all. You got to try to figure this out. And what you're going to figure out is these are all here. They're all non-metallic. These are all metallic. So therefore, it's going to be luster. Is how that chart is probably broken down. 12. The diagrams below show the crystal shape of 2 minerals. Quartz and halite have different crystal shapes primarily. Primarily means sort of mainly, or mostly in this case. That's what primarily means, so make sure you know that. And it is for internal arrangement of atoms. That is what causes properties for the most part. With the minerals that make it up, the elements that make it up, and how they're bonded together. We call that atomic structure. So I'm going to say also known as atomic structure. That's a key part to this. So for instance, diamond and graphite are made of the same composition of C, and yet they have very different properties because how those carbons are bonded together are different, give them very different properties. This one here, which physical property is most easily seen in the photographs. One of the key things you want to read here, the photograph shows several broken samples of the same colorless mineral. That's key. And the way it's broken, we did this in class, cleavage is the best answer. Okay, cleavage is what it's showing. It broke into those cubic shapes. Okay, and let me see here. Which mineral is most likely shown in the photographs? Well, you got to really kind of look through each one. Okay, so this definitely has cleavage, so I could eliminate any that doesn't have cleavage. Okay, so quartz does not have cleavage. Calcite has cleavage, galena, halite, so it could be those. Now, the reason it's not galena is because it's colorless mineral. Galena, if you look here, is very metallic-y silver, so it's not galena either. Calcite or halite. The difference here between them, calcite has this cubic cleavage, and halite has cubic cleavage. Calcite has rhombohedral cleavage, and rhombohedral cleavage looks like this, more like this. I'm never great at drawing it. Rhombohedral cleavage is like that, okay? That is what calcite has. Calcite's like this. But halite, the cubic cleavage is this. Therefore, it is for halite. 17, table below shows some of the properties of mineral. So, color white, hardness scratched by calcite. Therefore, hardness has to be less than 3. Greasy feel shows some flat surfaces, so that means it has cleavage. So, the color is white, and so less than 3, so it has to be less than 3, it has cleavage and a greasy feel, and it's white. It's going to be this one, talc. Now, talc is not an answer. It has to say it's mainly made of. That's the composition of talc. Okay, Mg is down here, magnesium. Si, you look down here, is silicon. O is oxygen, H is hydrogen. You can look right down here. Therefore, the best answer here is, and these can kind of mess you up, 3. Oxygen, silicon, hydrogen, magnesium. 24. This is represent the crystal structure of the mineral kaolinite. This is the crystal structure, how the actual atoms are bonded together in a mineral. An arrangement of atoms such as the one shown in the diagram determine a mineral's what? And the answer here is 3, physical properties. That's a key point to this whole thing. Which two minerals have cleavage planes at right angles? So you have to look at right angles. You're going to look for like what they often call cubic cleavage. So cubic cleavage is galena, and cubic cleavage is halite. And anything 90 degrees here, 90 degrees here, that's what we're looking for. Answer is going to be, let me see, quartz has fracture. So your answer is pyroxene at 90 degrees, and halite has that cubic cleavage. So you got to know that cubic cleavage means 90 degrees, therefore it's 4. The mineral graphite is often used as, this is one of the easier questions, I think, in that you go under uses here. Uses, graphite, use, pencil lead, lubricant. A lubricant is something like oil that reduces friction, it's slippery, and that is something that graphite's actually used for, like instead of oil at times. Use graphite on locks. It's a lubricant for locks. Parts plumbing fixtures sometimes. Okay, and then on the last page, this is the same question as earlier, so I kind of apologize. I mixed these things together, so the answer here again should be 1. Okay, for those watching this, please draw a star about the size of a quarter right there. Thank you. And then this, it requires some thinking here. You got to kind of figure this out. Okay, so, and you really have to like read this a bunch of times. What you should end up with is dolomite can scratch a copper pen. So dolomite, you got to look at the hardness of dolomite. Dolomite is here, hardness of 3.5. So maybe I want to write this down, 3.5. Dolomite 3, whatever works for you, 3.5. Dolomite can scratch a copper penny. That's true, because it's harder than it, but cannot be scratched by a fingernail. I cannot dig my fingernail, because my fingernail is 2.5. I can't dig it into this. It can't be scratched by a fingernail. So some of the semantics here are a bit weird. Like, but cannot be scratched by a steel nail. A steel nail can scratch it because it's harder. So you really, this one's a little tricky, but the answer here is 3. Okay, so I'm Mr. Gazda, and I approve of this message.